In this lesson, we're going to look at a few examples where we are evaluating and simplifying expressions involving rational exponents. And before we begin looking at those examples, let's review a definition we learned in a previous lesson. So remember this definition, and the definition dealt with this. If you have some expression raised to a rational exponent m divided by n, then remember now as long as m and n are positive integers greater than 1, then this applies. So the denominator is going to be your index, so you're taking the nth root of a raised to, and you could write this as the m, the numerator is your exponent, so you can write it on the outside, or you can write this as the nth root of a to the m power, where m is underneath the radical. So the definition of this notation can be written like this or like this. So as a review, so this little first part will be a review just to remind us how we use this. So if I have, let's say, 25 to the 3/2 power, then I know that, remember, the denominator is your index, so that becomes the square root of 25 to the third power. It is always easier when you're evaluating, it is always easier to rewrite the numerator on the outside. Don't write on the inside. It makes it a little bit more difficult. See, now this is easy to deal with. The square root of 25 is 5, and so I'm cubing that, 5 cubed, so this is 5 cubed. And so 5 cubed is 5 times 5 times 5, which is 125. Okay? Number 2, remember we had something like this, negative 27 to the 5/3 power. So again, that would be remember the denominator is your index, so that's the cube root of negative 27, and all that's being raised to the 5th power. So again, it's always easy to rewrite the numerator as an exponent on the outside. So the cube root of negative 27 is a negative 3. Make sure you put that in parentheses, and that's being raised to the 5th power. Now that's kind of a hard one, not a hard one, but it's very easy to make a mistake here. But remember what this means. This means negative 3 times itself 5 times. So I would just use a calculator. Now, it's being raised to an odd power, so if you do make an error, it's not going to matter. It will still be negative, but it really should be in parentheses. So parentheses negative 3 raised to the 5th power equals, and you get negative 243. All right. Now, that was an even number up here, then you need to be careful. You need to put that in parentheses because a negative number raised to an even power is always positive, so be careful. So a negative number raised to an odd power is negative, so that's why we see a negative here. Number 3, another one that we looked at in previous lessons was something like this. So you have x to the 4/5, and remember, you're going to rewrite this as radical expression, so that's going to be the 5th root of x to the, and you can write it like this, and I cannot simplify this any further because remember the exponent here is 1, and 1 is less than 5, then the index, or you can write it, the exponent on the inside does not matter. So I'm going to write this as the 5th root of x to the 4th power. And again, I can't simplify this any further because 4 is less than 5. So either one of those would be an answer there. And then we also saw something like this, where we had 2x raised to the 4/3 power. And so then that becomes the cube root of 2x like this, all raised to the 4th power. All right. Now, see how it's written? No issue there. But if you write it where 4 is on the inside, you got to be careful. This is how you have to do it. Listen to this. So it's a cube root. You have to put this in parentheses because all of that's being raised to the 4th power. All right. So you see the 4 is denoting that the 2x, the factors of 2x is being raised to the 4th. See, this is wrong to say this. It's wrong to write it like 2x to the 4th, because you do this, then you're implying that it looks like the only thing that's being raised to the 4th is x. All right, so you got to be careful. So you have to be careful. Okay, so be careful with this. So it's wrong to say that. All right, you got to put that in parentheses because all of 2x has been raised to the fourth. So just be careful when you put the the numerator inside the radical. That's why many students prefer just to leave it on the outside. Okay. All right. So now let's look at this. So this is going to be our new idea here, and so it's going to say something like uh, evaluate. It could say something like simplify. Anything of that nature. Simplify. It could say rewrite as radicals and simplify if possible. So in anything of something like that. All right, now simplify if possible. Okay, so look at number one. We'll write this number one since this is the new stuff. Okay, so we have this. We have x to the eighth raised to the 5/4 power. Okay. All right, so just like we did in the previous examples, I can the denominator is your index, so that becomes the fourth root of x to the eighth raised to the fifth power. Okay. Now, remember you got to make sure if you need to that you cover up stuff that makes it look confusing. So if I cover up that exponent, I see the fourth root of x to the eighth. So I know from previous lessons that remember what this means. This means what times itself 4 times is x to the eighth. So remember we did. This is easy kind because 8 is divisible by 4. So that's x squared, right? So this becomes x squared raised to the fifth. All right, makes you understand from a previous lesson that you know that the fourth root of x to the eighth is x squared because x squared times itself 4 times is x to the eighth. Okay, so remember x squared times x squared times x squared times x squared. 2 plus 2 plus 2 plus 4 is 8. So when you multiply like bases, you add exponents. Remember the product rule for exponents. Okay, now remember the power rule. So this is a power rule here. So when you have a power raised to power, you multiply. So this becomes 2 times 5 is 10. So the answer is x to the 10th power. All right. Okay, so this would be your work right here. So that's your work, and that would be your answer. Okay. All right, let's look at number 2. So suppose in number 2, I had something like x to the 12th, y to the 18th, all raised to the 4/3 power. Okay, all raised to the 4/3 power. All right, well, again, I'm going to rewrite this as a radical. So you're going to write it as a radical. So the denominator is 3, so that's your index. So that's the cube root of x to the 12th, y to the 18th, all raised to the 4th power. Put the 4 on the outside. Okay, that's the best thing to do. Easiest way to deal with this is to put the numerator as an exponent on the outside. And then remember from previous lessons, we know that I can rewrite this as a product of radicals. So this becomes the so again, forget about that exponent right now. Cover it up if you have to. Okay, cover it up. And so this right here becomes the cube root of x to the 12th times the cube root of y to the 18th. Now you got to remember now, it's all being raised to the 4th power, so make sure you put the 4 there. Okay, equal. All right, now the cube root of x to the 12th, this is easy kind. 12 is divisible by 3. So what times itself 3 times is x to the 12th? Well, that's going to be x to the 4th. 12 divided by 3 is 4. The cube root of y to the 18th, that's easy as well. 18 is divisible by 3. So what times itself 3 times is y to the 18th? Well, 18 divided by 3 is 6. So I get y to the 6th. And all that's being raised to the 4th. And now remember, you're going to use that rule that you learned in a previous course. And some textbooks will call it the power rule for products. See, that's a product here, and then you have a power raised to power. So basically, you're going to do this. You're going to take x to the 4th, raised to the 4th. You're going to take y to the 6th, raised to the 4th. And so then power raised to power, your power rule. So this becomes and put the answer here. So this becomes x to the 4 times 4 is 16, and then 6 times 4 is 24. So you have y to the 24th. Okay, so that's your answer. Let's do another one like number 3. So here's number 3. Okay, so number 3, you have this. You have, let's say number 3, you have x to the 20th, y to the 24th, and let's say my denominator is 4, and my numerator is 5, let's say. All right. So according to, so if I want to simplify this, if I want to evaluate this, I'm going to rewrite this rational exponent using radicals. I'm going to write this expression using radicals. So according to my rule, this rule here, okay, according to this, then the 4 becomes the index, the denominator becomes the index. So it'll be the fourth root of whatever inside that parenthesis, so x to the 20th, y to the 24th, and all that's being raised to the exponent, 5. Okay, so you see 5 divided by 4. Now, remember what you can do next now. Forget about that 5 for right now. If you need to, cover it up. Cover up that 5 if you have to. And so in a previous lesson, you learned that you can rewrite this as the fourth root of x to the 20th times the fourth root of y to the 24th. That's 4. Okay? But remember, though, you got to remember that all that's being raised to the 5th, so don't forget that. So you got to still put it in there. All right? Now, this is 20 is divisible by 4, so that's the easy kind. 24 is divisible by 4, that's the easy kind. So what times itself 4 times is x to the 20th? Well, 20 divided by 4 is 5, so that should be x to the 5th. Kind of makes sense, right? Because I'm going to go ahead and do this on another sheet of paper. You know that's true. You know that the fourth root of x to the 20th is x to the 5th because x to the 5th times itself 4 times, the index is 4, is x to the 20th. The product rule for exponents says when you multiply like bases, you add exponents. 5 plus 5 plus 5 plus 5 is 20. All right? Okay, and then the fourth root of y to the 24th, 24 divided by 4 is 6. So that would be y to the 6, but don't forget, that's all that's being raised to the 5th power. So don't forget your exponent 5. Now, remember the power rule for products in a previous course. The power rule for products, remember the power rule for products said this. Let me go ahead and write it here. The power rule for products said something like this. If you have A times B, so if you have a product raised to a power, let's say C, then I can rewrite this as A to the C power times B to the C power. So I can take this raised to the C, and I can take this raised to the C power. Okay? And notice that's what we have here. We have this right here raised to the 5th, and this right here raised to the 5th. Okay? So this becomes x to the 5th raised to the 5th, y to the 6th raised to the 5th. And so the answer then is, now remember the power rule. So when you have a power raised to the power, you multiply. 5 times 5 is 25. So x to the 25th, and then 6 times 5 is 30. Y to the 30th. And so that's your answer. Okay? And you know, and remember in a previous lesson and even in previous courses, you learned about the power rule for exponents. And so it kind of makes sense that this is going to be 25 because remember what this means. So if I go here and I kind of remind you, remember we're looking at x to the 5th raised to the 5th power. So this outer exponent here tells you how many times you're going to multiply x to the 5th by itself. So that becomes x to the 5th times itself 5 times, like this. Okay? And then, so that's 5 times here. 1, 2, 3, 4, 5. And so when you multiply like bases, you add exponents. So 5 plus 5 plus 5 plus 5 plus 5 is 25. All right. Okay, and so there's the answer there. Okay? And so here's your work. And that's the answer. All right? Number 4, let's suppose in number 4 we had this. We had number 4, we have 16x to the 20th power all raised to the 3/4. So 16 x to the 20th power raised to the 3/4. So again, if we change this to a radical, this becomes the fourth root. The fourth root is 16 x to the 20th, and all that's being raised to the third power. All right. Now, writing this as a product of radicals, this becomes the fourth root of 16 times the fourth root of x to the 20th, all raised to the third power. Now remember, the fourth root is 16, so 16 is a perfect fourth. So that's 2. 2 times 4 is 4. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's 2 right here. And then 20 is divisible by 4. So what times itself 4 times is x to the 20th? Well, 20 divided by 4 is 5. So it'll be x to the 5th. But don't forget, that's being raised to the third power. Okay? So now many students have an issue with this constant here. So be careful. You're still using this idea, power rule for products. So basically, you're going to take each factor, you're going to take this, raise to the third, just like this. See that? And you're going to take this, x to the 5th, raise to the third. And so 2 to the third is 8. X to the 5th, 5 times 3, power raised to the power, you multiply exponents, 5 times 3 is 15. So there's your answer. Okay, so there's your work. All right, number 5. That's number 5. So number 5, let's suppose we had this for number 5. Number 5, we have we have 4 x to the 10th, y to the 16th, all raised to the 5/2 power. So remember, your denominator is your index, so that becomes the square root of 4 x to the 10th, y to the 16th, all raised to the 5th power. Always put the numerator on the outside. And then rewriting this as a product of separate square roots here, this becomes the square root of 4 times the square root of x to the 10th times the square root of y to the 16th, all raised to the 5th power. And then I simplify each of these. So the square root of 4 is 2. The square root of x to the 10th, 10 is divisible by 2, so that's 5. So what times itself twice is x to the 10th? Will be x to the 5th. What times itself twice is y to the 16th? Well, 16 divided by 2 is 8. So y to the 8th, all raised to the 5th power. And then all I have to do now is simplify this, get rid of the parentheses. So you're going to say, you're going to use the power rule for products. The power rule for products. So you're going to say, well, that's going to be 2 to the 5th, x to the 5th to the 5th, and then y to the 8th to the 5th. Y to the 8th to the 5th. And so 2 to the 5th means 2 times 2 times 2 times 2 times 2. So that is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. 5 times 5 is 25, so that's x to the 25th. 8 times 5 is 40, so that's y to the 40th. So there's your answer. All right, number 6. All right, number 6, let's suppose we have this one. We have negative 64 x to the 3rd, y to the 6th, z to the 15th, all raised to the 2/3 power. All right, so my index is now 3, so it'll be a cube root. So this becomes the cube root of negative 64, x to the 3rd, y to the 6th, z to the 15th, all raised to the 2nd power. And so rewriting this, I can rewrite this as separate products. So this becomes the cube root of negative 64 times the cube root of x to the 3rd times the cube root of y to the 6th times the cube root of z to the 15th, all raised to the 2nd power. The cube root of negative 4, the cube root of negative 64, we know is negative 4. Negative 4 times negative 4 times negative 4 is negative 64. The cube root of x cubed, 3 divided by 3 is 1, so that's just x. Kind of makes sense because we're asking ourselves what times itself. 3 times is x cubed. Well, x times x times x is x cubed. 6 divided by 3 is 2, so the cube root of y to the 6th is y squared. Kind of makes sense because y squared times y squared times y squared is y to the 6th. And then 15 divided by 3 is 5. So it'll be z to the fifth, all raised to the second power. One more step and you're almost done. So then we're going to take each of these. So again, we're using the power rule for products to take each factor, raise it to the c power. And so we're going to take negative 4, raise it to the second power. Now be careful, put that in parentheses, because any negative number raised to an even power is going to be positive. We take x, raise to the second power, just like this. Take y squared, raise to the second power. And then take z to the fifth, raise to the second power. And I'll simplify each of those, and that'll be your final answer. Negative 4 times itself is 16, positive 16. X times x is x squared. Y squared squared, 2 times 2 is 4, so it'll be y to the fourth. Z to the fifth squared, 5 times 2 is 10, so z to the 10th. All right, and so that's it. So that is just an extension. So what we just did was an extension of what you learned in the previous lesson on this topic right here. All right, so that'll be the end of this part of the lesson.